Welcome to a special episode of the Nero Show featuring Head of Engineering at Tour Magazine, Robert Kühnen. Robert's been performing objective scientific testing on bikes for over 2 decades. And today we want to find out all about that testing, how they do it, what bikes perform best in those tests, and where he sees both the industry and the magazine headed. We're going to start with just a little bit of story time on how I was introduced to Tour Magazine. This has been a complete adventure for me. So the way you were introduced to me anyway was anytime Jesse and I would talk about a bike, its performance, maybe we would be sitting here and comparing them to each other, the show would go live and I would get half a dozen to a dozen Instagram messages from people after the show, and they would look all like this. They would be a screenshot of this list of bikes with numbers next to them, and there was kind of a ranking system, and they were sometimes alluded to the bike that I'd talked about, and the comment was always the same. It was like, Tour Magazine have already worked this out, Chris, seriously. And it was like, come on. And so this was like, I'm like, what is this thing? Yeah. Tell me more about it. So could you potentially go just a little bit into maybe Tour Magazine for the Chris Millers who hasn't been receiving these DMs for the last 12 months?
Yeah, it goes back to the 80s. Hans-Christian Smolik, my predecessor at the Tour Magazine, he introduced the cycling magazine world to objective testing methods. And this goes back to the 80s. So he made the first stiffness rigs and also worked with universities and came up with interesting stuff. And we developed from there, and our goal was always to have objective testing in place. So, I mean, we are all riders. We love to ride our bicycles, of course, but we want to have an objective scoring system. So this is the base of everything. And aerodynamic is one part, but we also do a lot of other testing.
Let's get into some of the testing then. Just first off, first question I have is, how do you decide what bikes to test? How do you get the bikes? What is that? Is there a process there?
First step is to make an editorial choice. What is an interesting story? So if there's a new bike popping up, that's usually not enough to have a story. I mean, if it's a really famous brand and a bike everyone is waiting for, then we do a single test. But usually we do comparison tests. So we bundle bikes with some kind of bracket, bikes from Italy, cheap ones again, expensive ones, Aero bikes, lightweight bikes, whatever you can think of. So it's an editorial choice. And then we ask the manufacturers to send in the bikes, and we get them for free. We test the bikes and send them back. That's a process. So
I'm really curious about this actual testing process. How is this testing done? Because it's all well and good to say the aero drag of the bike and the frame, but I'm really curious to go into the details on how you're running these bikes through the gauntlet. So what is the testing that you do? From let's start off with aerodynamics. What's the testing process?
The aero testing is performed at the GST wind tunnel. That's a privately owned wind tunnel at the Airbus facility in Immenstadt, that's southern Germany. And we have a relationship with this tunnel since 10 years. Before that, we went to a tunnel in Dresden, eastern Germany. And the GST tunnel this is the best tunnel I've seen so far. And we have developed a process together which is quite nice. So the usual process is we set up the bike in the wind tunnel, and I've made a special dummy, a moving leg dummy. A dummy without upper torso. We got rid of the upper torso because it's a source of error. You introduce a lot of wind resistance with the upper body, but there's not so much interaction between upper body and the bike. So it's an error source from an engineering point of view, the upper body. And I wanted to get rid of this failure. Before that, I had a full body dummy, but without moving legs. So the next step was moving legs, but no torso. Looks a bit strange, and we get a lot of questions from the readers, but from a technical point of view, it makes sense. And we have these moving legs, and they introduce all possible leg positions during the measurement. And this is a key to get the right interaction between the legs, the rider, and the bike, to have all these different leg positions in your measurement. It's not about the speed of the legs, it's about moving not that fast. It's about the interaction in all these different positions. And to be fair, you need to have all these positions in your measurements. And the cool thing about the GST run is we do 41 measurements in one sweep. So we do a sweep from -20 to plus 20 degrees yaw. So we introduce side winds. And this is a continuous measurement. So we take these 41 measurement points in one run. It takes only 1.5 minutes. And then we have the complete information about the bike and its behavior in all these different wind conditions.
And so, yeah, when you talk about normalizing the position of the legs on the model, is that do you mean kind of like position over the bottom bracket, that sort of thing, the riding position, ankle position?
In fact, we spent most of the time in the tunnel adjusting the dummy.
Okay.
It takes a lot of time. I've made special laser rigs from the side and from the front to ensure that we have always absolutely the same position. And we have a reference bike. We start each measurement with a reference bike. And so we can refer it with the last run and the run before and so on. And this gives us an idea how good our measurement is set up on this day.
So the dummy's on the reference bike, and that's positioned with the lasers from the side and the front, and then you swap the bike over and get the dummy in the exact same position.
Right.
Right. Okay. Interesting.
So we spent really a lot of time, and this was all a learning curve. It's the dummy introduces more resistance than the bike itself.
There's a sort of buzzword going around a bit at the moment, which is this turbulent air thing. Obviously, and I'm sure you've heard it referred to as, just the reality, or trying to mimic the conditions as much as possible of being outside.
Yeah.
So with your wind tunnel, and you mentioned the yaw angles and that sort of thing, do you think that is potentially a factor where the wind tunnel is not capable of taking that into account, or do you think that turbulent air is bullshit and we shouldn't even be considering it in the first place? Like, would you have a take on that?
Yeah, sure. The wind tunnel is good, but turbulent air would be better.
Okay. Fair enough.
Yeah, I mean, you can always improve, but I mean, we already achieved a really high standard. And turbulent air definitely happens outside. So this would be a nice additional information.
When I've sort of looked back at some of the testing, there's reference to these standardized wheels that I think you maybe used to use. Was it Zip 404s that you used to use?
We still use them, Zip 404.
Okay. And now, so you used to test with the Zip 404 and then the wheels that came stock on the bike. Now you're just testing the stock build as it comes from the manufacturer. Is that right?
No, that's not right. We still test with the Zip 404s. Sometimes we miss to publish the values. Yeah, that really happened. But every test is run with Zip 404s as well to get an idea how good the bike could perform. But the scoring is done with the wheels coming with the bike.
Yeah. So the aero drag number that I've seen in some of the cutouts from the magazine, that's with the stock wheels that come.
Right.
Okay.
Can we talk about the fastest bikes that you've tested?
Yeah, sure. The fastest bike so far was Simplon Pride 2.
You saw that one the other day, Chris. Someone brought that up.
Yeah, I was so. I actually wanted to talk about it on the show. To be all completely honest, Robert, I had never heard of this brand. Like I'm coming off in this show as someone who's no idea about cycling. But it was someone on Instagram who forwarded this on to me and was like, hey, check this out. Like, this thing's blowing the water out. And I suppose my question in relation to that is, can you look at a bike like the Pride 2 from your perspective with your experience and say, oh, that's going to be a fast bike? Like, can you see the Aero? Can you see the Aero in that frame?
Yeah, we had our learning curve. I think we can tell it now, yeah, more or less.
Would you be able to potentially talk me? Like, I'm looking at that frame now. So, are we talking about that massive head tube? Like, what can you maybe point to a few factors in that frame that you go, oh yes, this is going to be fast?
Yeah, this frame has deep profiles, a small silhouette, and it's really clean. Huh? That's it. I mean, it's not that mysterious. I think Simplon was pretty fast in adopting to the new UCI rules. They were the first to move to these super deep profiles after the 3-to-1 rule was skipped. And this is the main reason why they are leading the list right now. And of course, I mean, this did not came out of the blue. The aero development was done by Swisside. Swisside is the aerodynamic company which also is responsible for the DT products, for the aerodynamic design of DT. And they have a background in Formula One racing, so no surprises here. And if you look at these super fast bikes, I mean, it's quite similar to an S5. The whole principle.
Is there a bike that you've tested relatively recently that you looked at when it came in and went, okay, this is going to be pretty fast, and then you put it into the tunnel and the results weren't there?
We have had funny things. We had another German brand, Stevens, you might have known of them as well.
Yeah, I know that. Yeah, I've heard that.
And they are more famous for cross bikes. But they came in with a new bike, an Aero bike, and we knew that this bike has never seen a tunnel before. So they did all the development based on CFD, on simulations, and this turned out to be quite good. I think we landed at 207 watts, something like that, or 208, and not too bad for a bike which hasn't seen a wind tunnel. It went to a wind tunnel the first time with Tour Magazine, and performed well.
Aero by visual design in a computer somewhere. Interesting.
Well, I mean, CFD can be a serious tool.
I'm curious about the builds, because as you kind of mentioned there, between the Simplon and the Cervelo, the drag differences in watts between a lot of these top bikes now are quite small. What sort of difference have you seen in terms of little tweaks with the components? For example, the Specialized Tarmac SL7 versus the SL8, which I think in your testing, they were pretty much the same. There was a couple of watts possibly, but the SL8 comes with the integrated Aero handlebar. Is that, I mean, and then if I'm comparing another bike, the Canyon Aero comes stock with the 60mm DT Swiss wheels. Like, in terms of the package, is there, if you add, how many watts are we looking at between different stock builds? Because if you're splitting hairs between sort of 2 and 3 watts between bikes as a consumer, but there might be a handlebar difference that could make up that gap.
Yeah, the differences between the good wheels are not that big nowadays. We're talking about 2 or 3 watts. That's it. The tire makes a difference. There are very well performing tires in the wind tunnel, and there are bad tires. So the tire choice is in fact a rather big thing. If you have a not performing tire, then you will stall early. So at higher yaw angles, the tire it's a leading edge of the wheel, and so it's an important part of the whole profile. And the aero performance of the wheel totally depends on the tire.
In the magazine, the reviews that are written about the bikes, including the testing data. So say Canyon Aero scored 203 watts in the drag. But my who writes those reviews? Is it do you write those, or does someone from the magazine side write them?
It depends. Sometimes I write the review, but we have a test crew, and usually the guys who do the riding, so
there we go.
Who spend the time on the road with the bike, they do the writing too.
Okay.
So
yeah, one of the, I guess what you would say is kind of the contextualization of the data that you're giving, or the interpretation of it, is that between two spec builds of bikes, one might come with 25mm tires and another one might come with 28mm tires. So the one with 25s tests faster, maybe by a couple of watts because the front tire is narrower. But then in the review, the magazine says, well, this bike is faster because it tested 204 watts versus 206. But there's kind of another level of, why is that? Well, that came spec with a narrower front tire, which could provide those aero savings. Now, yeah, you're testing the bikes. It's maybe not your job to do that. Do they attempt to make those kind of explanations in the reviews of the data?
When we have the space, then we do these explanations. Yeah, sure.
I think it is pretty important, especially if you compare the SL7 to the SL8, and the aero drags from the frame appears to be the same. It's just that one has an aerodynamic handlebar, so it tests faster.
Is it too early to dive just a little bit into the disc rim stuff, just in terms of whether we saw a difference when disc came in?
When disc came in, there was a difference. Yeah, I mean, you introduce another piece of material, and you can't get rid of the disc, so the disc introduces some more drag. That's true. And right in the beginning, we had 2 or 3 watts more, but then things started to develop, and you can really hide the calipers quite well. And now there's no big difference anymore, so it's more or less equal now.
We asked you about the bikes that were perhaps look fast, and was there any that tested slow? And your answer is kind of no. If they look aero and have deep tubes, they're probably going to test quite well. Are there any, on the other side of that, are there any bikes that surprised you in how fast they tested, given how they looked when they came in for testing?
Yeah, the most surprising might be the specialized tarmac.
The SL8 latest version? Yeah, tested quite well, given how sort of thin the tubes look, especially in the back end.
Yeah, this bike is quite fast for its overall design.
Do you have an opinion on that? Because it's interesting. Like, I look at that SL8 as just a layman cyclist, and it looks very similar to something like a Giant Propel, the new Giant Propel. But you're right. Like in your testing, the SL8's done quite well. Is there? Do you have a theory on that? Is there anything you can think that might be causing it?
I think they just have done a brilliant job. They just focused on things which matter, obviously, in terms of aerodynamic, and I think the overall package is pretty good. What they've done there. We've done test rides last week in Italy, and I could join the crew for this test, and I was riding the SL8 on downhill stretches, and the difference to other bikes is quite amazing in terms of stiffness. And so the overall package, lightweight, really high stiffness, and quite good aerodynamics. That's a winner in my eyes. Yeah.
Just in terms of the data that's collected, how do you find it compares year to year? So if a bike tested at 205 watts this year, for example, is that comparable to testing you might have done 3 years ago? Is that are the wind tunnels accurate enough year on year to have that comparison?
Yes.
Okay, that's really impressive. That's managed to do that.
It's always, you have more precision when you compare within one run. So within one day, our measurement precision is better than when you compare a measurement from 2 years ago. But it's still quite good. I would say it's plus minus 1 watt if you look at the data from 2 years ago. And it's rather plus minus 0.3 watts if you are within one session.
Pretty impressive, given how much is moving around and going on in those tests.
Yeah, that's crazy stuff. That's absolutely crazy. And this is why I like the GST tunnel. It's so good.
Another question in terms of the aerodynamics of these bikes. Are there any common features? What are the main common features that you've seen between the top performing bikes? And are there any brands you can think of that aren't using those features that it kind of confuses you why they aren't taking advantage of that?
Well, aero benefit means a low frontal area, so small silhouettes, deep profiles, especially the head tube and the fork legs, and then dropped seat stays, a narrow seat post, which hasn't to be super deep, I think. These are the main features. It's quite simple. But when you create the bike, I mean, how do you make the transition between these tubes? I think this is a tricky part. And but overall, the equation is pretty clear. So I mean, Stevens is a good example. They just copy and pasted the process and made their CFD stuff and came up with a pretty good result. So
what's the model of that bike?
Arcalis.
That is, okay, so the Stevens.
Stevens Arcalis.
Okay, interesting.
207 watts.
207.
207 watts.
So what were can I ask, in terms of 2023, what were the top 5 in the tunnel?
Seems to be the Scott Foyle RC Ultimate with synchronous wheel, 60 millimeter deep. That was 203.
And the Stevens was 207.
7.
Yeah. I guess I'm going to say what's the difference, when you're going to say, well, the difference is 4 watts. But if in your experience, sort of probably riding some of these bikes, is that a significant difference? I mean, is 4 watts in your testing, is that a lot? Is that negligible? Sort of.
No, you won't feel it.
If you're looking between 2 bikes, how many watts difference in your testing would you say is going to be noticeable for someone racing at a kind of a club level?
I think 10 watts and more, you would notice. I mean, the real differences are between these aero bikes and non-aero bikes. And we're talking about 20 watts or 30 watts. And that's for sure noticeable, yeah.
It's good to know, yeah, because it can get quite overwhelming when you're comparing the results.
And I mean, you need to take into account these single watt numbers. I mean, there's a lot of maths involved to get one single watt number out of 41 measurements. You need to check the graphs to be sure what you're comparing in which situation, because if you're going really fast, and if there's no wind, no ambient wind, then we're talking about the flow at 0 degrees. So you should compare these bikes now at 0 degrees to get an idea how they perform in this situation. In our normal procedure, we calculate with 10 km per hour ambient wind, which is quite a lot. We won't see that much here in Bavaria. And so the single number has to be taken with this information in.
Could you explain that? So the wattage number overall that the Tour magazine gives is that, what did you say? That is factoring in a 10 kilometer an hour
ambient wind, yeah, because we introduce side winds, and you only see a side wind as a cyclist when there's some ambient wind going on. Otherwise, you won't see flow from the side. And we have a weighting function, so we process the data and calculate with 10 km per hour ambient wind. And then we have a weighting function which processes all these measurements we've taken, the 41. And measurements taken at 0 degrees or at lower yaw angles are more and more important in this equation than flow was coming at 20 degrees. And depending on the ambient wind you're calculating with, you will see different overall results. So if we look at less ambient wind, then we will get a different profile and a different weighting function and a different result.
I wish I had more knowledge to dig into that. I think, you're at the limit of my aerodynamic expertise there.
We take into account the sailing effect when we introduce side winds. And the whole thing developed because in Kona during the Hawaii Marathon triathlon, they see a lot of side wind. That's where the whole discussion with yaw angles popped up. And these guys really see a lot of side wind because there's a lot of wind on Hawaii. And when you ride here in Bavaria, there's not that much wind. And so you're more into it's more a kind of laminar flow when you go here, and less side winds. And then you don't talk that much about the sailing effect, and the yaw angle is not that much important anymore. And this is a different measurement then. We do this measurement, we do all these measurements in the one run, but the question is how do you handle the results? And if you're interested in zero ambient wind, then you look at the drag numbers at 0 degrees. And in the best of all worlds, we would print also the graphs with each bike, and then you could compare the drag numbers at 0 degrees and could compare the drag numbers at 10 degrees and so on. And we just put it together to one single drag number, the watts we are presenting. But this is for a certain wind profile.
That makes sense. So it's the bike speed is at 40k an hour, but then also a 10k an hour wind coming from whatever angle, your angle you've moved it to. Is that kind of sum that up?
Yeah.
Okay. Just out of, I want to move on as well to the stiffness testing and maybe some of the other testing you do, but in terms of all that data, obviously it gets published by the magazine. Is there any way can people get access to that? Is it something that the magazine would kind of sell a membership to, or is that just kept in-house?
Right now it's kept in-house, unfortunately.
I'm surprised the industry hasn't sort of tried to knock that down and come in and have a look at all the data from a bike industry perspective to get their little grubby mitts onto that. They would be very, very happy. Which kind of, I don't know if this is particularly relevant, but it always interests me when a new bike is launched, etc., and we all hear the claims from the manufacturers. This is this is 14 watts faster than the previous generation. Blah 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 blah. Do you see these claims coming out and sort of giggle at them and fact check them in a sense, or most of the time they're being relatively honest and upfront about the claims that they're making about their own bikes?
We don't care that much about the marketing talk. We just draw our measurements.
Have you ever, just out of curiosity, as Chris sort of said, is there any been a claim that you've seen that you've then looked at your data and gone, yeah, that I've got no idea how they got to that conclusion? Anything come to mind?
No, not really. I think most of these claims nowadays are quite good and serious and not too crazy. And I mean, if you use different measurement methods, then you will come up with different results. So
I actually said the same thing, Chris, when the SL8 got released. I said, actually, if you actually look at the specialized marketing claims and read their white paper, what they say it's doing is actually pretty modest. So I think, in terms of that specific case, it was.
I mean, I did some calculations. I have a simulation software where I can put in our data, and I did simulations for the last Tour de France. That's one thing you can Google on the Tour website. That I call the Tech Briefing, Tour de France Tech Briefing, and these ones are in English available with all the associated data. And I did some calculations with these bikes, and the overall numbers, how many time you can save, were a bit lower than the numbers provided by Specialized. But the trend was always okay.
Should we move on to some of the stiffness testing? Because I know this is another key part of the reviews when you're putting out for the bikes, also contains stiffness testing. Can you run us through how that's tested and what area of the bikes you're testing for stiffness?
Yeah, we try to get a complete picture of the bike, how it behaves on the road, and we do a couple of stiffness tests. So we do we test bottom bracket stiffness. This mimics a sprint out of the saddle.
Yep.
Then we test front comfort and rear comfort. We've just updated the procedure. Front comfort includes fork, handlebar, and stem. And just put a load on the handlebar and measure the deflection. So we get a front stiffness, and we have a rear stiffness. We introduce a load to the seat post, quite high load. And so we have the deflection of the seat post at a certain seat height and the deflection of the seat stays if there's some. And then we have overall stiffness, we call it riding stability. And this one has also been modified right now. And there we load the fork and the front part of the frame with the side force coming from the tire. So we test the whole stiffness chain. We make a measurement with a wheel dummy and a super stiff wheel dummy, introducing a side force into the whole construction. And then we have the chain where the forces flow from the ground to the rider. And we take this as a measurement for the riding stability.
Incredible. So is the you mentioned the seat post stiffness test. So is that testing for compliance of the frame as well, or is that only testing the?
No, it's the overall compliance of the system. So if the seat stays are flexing, they will flex in this test.
And is there? I mean, the common theme is that a thick aero bike is overly stiff. and then a smaller tubed non-aero bike is less stiff. Does that rude sort of claim hold true?
Not exactly. I mean, it depends on what type of stiffness you're looking at. I mean, in a vertical plane, an aero bike is stiff. That's correct. And the first aero bikes were not so nice to ride because there was no compliance at all. But then things developed. Now we have better seat posts, D-shaped seat posts or extreme long seat posts and lower clamping areas. And they put a lot of energy in designing aero designs with some compliance built in, and it works. So modern aero bikes, they have some kind of built-in compliance. They are not too bad, and they are nicer to ride than the first tries. And the traditional round tube bike, that totally depends on the dimensions and the geometry if there's some compliance built in. The seat post obviously is very important because it's just a single tube, and if you have a single tube, the diameter is very important and the length to get some deflection. And so a small seat post, small seat post has more deflections than a big one with a large diameter. So the equation is. You want to have long and slim seat posts, then you have some comfort.
You've probably sort of answered this question though, but just the same in terms of you look at a bike, you can tell that's going to be fast in the aero tunnel. Can you look at a bike and potentially name a bike and go, that's going to be overly stiff? Are there?
Yes, I mean if you look at the Klein Quantum Pro, then you can see that this one is really stiff. I mean, these big round tubes and plus a thick, round and short seat post, that must be stiff.
I guess we're all under the assumption, at least as far as I'm aware, that sort of stiff. Take out the seat post, that seat post measurement you were talking about. That stiffer is better. So stiffer bottom bracket's pretty clear. Stiffer head tube. If we're looking up marks in the data from the Tour magazine, is higher stiffness always better in those areas? Is there any examples or situations where that's less ideal?
When we talk about tarmac and nice pavement, I would say more stiffness is better, yes. And things might change a little bit when you go off-road. I also work for the bike magazine, so I know off-road riding as well. And we did a blind test with prepared mountain bikes in a bike park, and I prepared bikes to have different stiffness values. So they had a blind test with same looking bikes, but the stiffness was manipulated, and the manipulations were quite big. And they had a hard time to figure out which one was a stiff one and which one was a weak one under off-road conditions and lower speeds. And on the road, it's quite the opposite. Then it's pretty clear. I mean, if you go fast, I had the experience last week. If you go fast, you need just a few hundred meters to really feel the difference. And then more stiffness is better, of course.
I don't have many questions about the comparing bike stiffness because I struggled to find the stiffness ratings. The aero claims were a little easier to find. We can say that the top level of the aero bikes, the drag is quite similar at the top level of them. What's the difference in stiffness between those top level bikes? Is there a bigger variation in stiffness than there is in aerodynamics, or they're all quite uniform?
No, there are differences. The new test, I haven't done so many measurements with the new test, but I can give you numbers for the S5, for instance. So an S5 is, in terms of riding stability stiffness, it's 20% weaker than a tarmac SL8, for instance. And you can really feel this difference.
Is there any other bikes that you've run through that latest round of testing that you have the data on hand for? I'm just interested.
The SL8, I mean, we limit the values. So our limit now is at 9 Newton per millimeter, and everything above gets the same score.
Why is that?
So why that? I mean, this is always a trick with scoring systems. You need to adjust your scale to something.
Oh, so you scored when it. Oh, I see what you mean. Okay.
We have seen the highest values we've seen so far around 11. Yeah, 11 was the highest value. You have to make a decision. Our feeling was that everything above 9 is quite good. So, but yeah, maybe we adjust the scale at some point.
So if a bike's one's 11 and one's 10, they're all getting the top mark in the sort of the star rating, if I want to say that it's given in the magazine write-up.
And we also, the funny bike was we also rode a Vitus Carbon 9, a bike made in approximately 1988, one of the first carbon bikes in the Pro Peloton. And this one is so weak, it's wobbling all over the place. And we took it with us, and just for the fun and for comparison and for nice pictures, of course. And this one it's really amazing that the guys rode these bikes at the Tour de France. And you can't hold the wheel of a really fast racing bike from today.
What do you have the number for that? Or was it like 2 on the stiffness?
It was it comes up at 5.
So half as.
I am actually truly blown away by that number that you just gave, that the S5 is 20% less stiff than the SL8. Like if we had that conversation about some of the aero testing and you'd said the SL8 is 20% less aerodynamic than the S5, that would be an enormous number. So is that a big margin? Is I suppose my question. And also on the back of that, the rhetoric around the S5, the limited experience I've had riding it, it's a pretty stiff aero bike. Like, to think that the SL8 is 20% stiffer than that, it blows my mind, actually. And so, yeah, is that a big number?
You can feel it, so it's quite noticeable, yeah. But the riding impression of the S5 is a rather harsh bike compared to the SL8 in terms of vertical elasticity.
Do you have those numbers there with the vertical compliance numbers between the SL8 and the S5?
I don't have the numbers at hand right now, but I think there's a big difference, yeah. A lot more than 20%, then we're talking about, I think, 100% or even more. So the SL5 is meant to be ridden on really good roads. That's what I suppose, yeah.
No, but it's all about the package, Jesse. See, I'm on the 30 mil tires running sort of 55 psi. So you got to take all this sort of, actually, well, that kind of, I suppose, builds me into the another kind of angle I could take this, Jesse. Again, tell me to shut up. But in terms of so the bike gets tested by yourself through stiffness and then the wind tunnel, and then it goes out to be ridden outdoors by the reviewers. Are the reviewers aware of the results when they go out and ride the bike, or are they just getting the bike and riding it and then it's all put together at the end?
It depends on the aura. There's no clear procedure. Sometimes they have the numbers beforehand, sometimes not.
I see what you're getting at there, Chris. If someone's told you the SL8's 5 out of 5 stiff, and then they go ride it and they go, it is pretty stiff, isn't it?
Well, the handlebar is stiff of the SL5. It's quite stiff, and the rear end is stiff. So the overall impression can be or must be that this is a stiff bike, of course, yeah. But when you compare these bikes on a downhill stretch, then you will see different behavior.
Have you seen an experience where a bike you've done the testing, you've done the aero testing, etc., and you've got an impression of it, and then it goes out to be reviewed by the guys riding it, and then they put their element together and the review comes out, and they are somewhat split in the sense that maybe the guys riding it are using phrases like, gee, it was sorry, Jesse, it really held its speed really well outside and was stiff and fast, and then they combined it with your results, and it turns out it's actually a dog of a bike, and it's like the worst aerodynamics you've ever seen. Like, there's a total mismatch in terms of what the person outdoor felt compared to the reality. Is there been any experience of that?
No. When I see the text, then the guy who was riding the bike already got the numbers, so if they had the wrong impression, they could adjust it.
Are you the only independent sort of body doing this kind of testing?
I think so, yes. Well, occasionally there are tests done by other publications, but not on such a high level and not so continuous. So I think in the end we are unique. Yeah.
So how do we broaden your? We need to broaden your audience beyond the German borders
internet forums
and get this out there.
Yeah, I would love to do it. Yeah, it's hard to understand how we behave, to be honest. Yeah, but I'm responsible for the technique here, not for.
So how do we? I guess the best way to access this data is to search Tour Magazine's website for those of us overseas that can't get access to the magazine. Use the search function on the site.
Currently, yes, yeah.
So if I search for a bike, like if okay, so here's the article you've written, the SL8, and it's got the numbers in there. Okay, 209 watts. So yeah, with a bit of, it does take a little bit of work, but for those that are curious, if there's a bike you're interested in and you want to see the numbers, go to a magazine, use the search function, and if you search through the articles, you should be able to bring up the test data on it.
One of the trends that I've started to see a little bit on the frames are these wider forks. I think I saw it was it the BMC Road Machine R had that very wide fork.
Yeah, Stork is doing it. Yeah, there are two strategies: wide fork legs, and very very narrow ones, and both work. Both seems to work.
Because that's quite a dramatic look from my perspective, anyway.
Yeah, there are extreme bikes out there. We haven't had it in the wind tunnel, but there was this Hope track bike made in the UK with super wide and super narrow fork legs and also seat stays. I think they tried to bring the fork legs in front of the legs of the rider, and same was true for the seat stays. So super slim profile and really wide legs.
So there's the aero testing, the stiffness testing, which includes compliance. Is there any other tests that you put the bikes through, or is that it?
No, these are we test, check the paint and some more details. But overall, what goes into the scoring is our score of the components. We do component tests as well from time to time. When the new group set pops up, we do testing with the group set. So we have a scoring system for the components as well, and these go into the rating of the bike as well, yeah.
Well, what sort of testing of the group sets? Do you mean like between like a SRAM Red Axa C-Tap and a Shimano Dura-Ace?
Yeah, we look for shift quality. I check the chain wear. I have a machine to test chain wear. We look at shifting speeds. We look at stiffness of the cranks and other crazy stuff. And we put it on the brakes. Of course, we have a test rig for the brakes as well. And we put all these numbers together, and then we come up with a score for the group set.
Is Shimano Dura-Ace your top-rated group set at the moment?
I think it's on par with the top group sets of SRAM and Campagnolo. And one very interesting test we're doing is tire testing. Tire testing is really fascinating, and this plays a big role in our testing. We have our own methods to test rolling resistance. We have our own methods to test the grip and puncture resistance of the tires. So we do a lot of in-house testing with tires. And tires are part of the performance equation. So if we're talking about aerodynamics and tire performance, that's why we are so much into tire testing. And this can be really eye-opening as well.
I guess you'd use that data when you review the tires as a standalone item, and then. So does that also factor into the bike review, the tires that can come stock? Is that the level of detail that the reviewers would go to?
Yeah, it's both. We do these tire tests where we compare tires, and it's also part of the overall score of the bike. Yeah,
that's such a good level of detail to not only just factor the tires in, which is probably most reviewers to say, hey, it comes with a GP5000, but to say it comes with a GP5000 after you've independently tested it on your own is a whole nother level. That's really cool.
I did reach out to a couple of sort of industry type people, I suppose you'd call them, in Australia, and said we were going to be talking to yourself and what was their opinion on Tour Magazine. It's really interesting because it's quite split because on the one hand, that narrative of, oh yes, Tour magazine, we've heard of manufacturers and brands that specifically make their bikes or target their bikes to perform well in your tests because they know how important the results are ultimately to their sales. Is that something that you're aware of, or I mean, obviously it doesn't impact you at all, but is it? Have you heard that kind of thing as well?
Yeah, I'm aware of that. Yeah, sure. I mean, and it makes sense from a manufacturing point of view. I mean, as long as you believe in the methods we're using. I mean, if you think that's rubbish what they're doing at Tour magazine, then you shouldn't adapt your development to meet these goals. That would be stupid. And I think the better companies, they do their own stuff, but they keep an eye on our method as well. And so they come up with a solution they believe in.
In terms of the road bike testing, if you had unlimited time and perhaps an unlimited budget as well, is there any other aspects of the bikes that you'd want to test or different methods you'd want to use to get a more complete picture of how fast a bike is?
Of course.
What would that involve?
Yeah, I mean, more dynamic measurements. Okay, we talked about turbulent air. That would be an issue, but it would also be an issue to look at the dynamic behavior of the bike on the road. I occasionally did these measurements, so put in accelerometers on the bike and picking up signals to compare the behavior of the bikes in a more detailed way. But this is super time consuming, and to come up with a standard for that's quite difficult. Yeah, but I would love to do it. Yeah.
Do you test your in the tunnel with a bike computer mounted to the bikes?
No, but it does make a difference. No. We have tested if there's a difference. There's no difference. It's below the measurement resolution.
Interesting. Okay.
We haven't talked about wheel behavior. We have a special procedure to check the wheel behavior in the tunnel. So the tunnel is you put a bike on a scale, right? You measure the frontal drag. We also measure other forces, but the frontal drag is important for the rider. But there's a second scale involved, which is put between the main scale of the wind tunnel and the front wheel, or the drum spinning the front wheel. And this second scale is meant to measure the torque introduced into the steering system by the side winds. So we can measure the side wind behavior in the wind tunnel. How much force will you feel in the handlebar when you hit the side wind? Or
wow.
Yeah. So this is the second measurement we do. And this is quite interesting because the drag numbers are quite the same now with the good wheels, but the behavior in side winds can be very, very different. And there we talk about twice the force if the wheel is not constructed very well. So the big difference are now in the handling, not in the drag.
I didn't. Oh, that's really cool. Okay.
Yeah. Is there any common trait? Because I'm so happy you said that, because I feel this on the road between wheel sets. Is there a general rule, like the wider the wheel, the better it performs in terms of how you're affected in crosswinds? Or is there any generalization you can use there?
No, I have no.
What are the better performing wheel sets in crosswinds?
A better for performing one. The last surprise was a small German company called Leze. They have amazing fast wheels with amazing stability built in, and they're quite cheap as well. So it's a triple win.
So they had they were quite competitive drag wise, but also dealt well with this crosswinds.
Right. Yeah.
Are there any wheels that you think performed quite badly that are well known in terms of the stability in the crosswind?
Yeah, the stability also depends on the height of the rim. So if you have more sailing area, then you have higher forces. This is the rule of thumb, and it's always true. And the funny thing is, these super D wheels, the drag numbers are not so much better than there's no reason to have 80 millimeter D wheels. That's stupid to ride them, because the drag coefficient is more or less the same, and you introduce a lot more side force. So I would go for less deep wheels. Let's say you can have a real nice aero performance with 40, 45 millimeters or 50 millimeters, so no need to go any deeper in my eyes. Then we talk about maybe 1 or 2 watt less drag, but the sidewind behavior becomes a lot worse.
Having currently owning 80 millimeter wheels, I stand by that, because you couldn't easily get blown off the road, and I'm about 80 kilos, and I still, if there's a bit of wind up, struggle with that. That's what the MVs are quite well renowned for, is that at a similar depth to other wheels, most people claim that they deal well with that crosswind stability. Have you tested any bikes that come with MVs in terms of that side wind?
Yeah, for sure, but I don't have the numbers at hand. We should look at, there are so many numbers, but yeah, there are quite many modern wheels which behave quite well in, in the crosswinds. So it's the latest example is not outstanding, but it was outstanding because these bikes are also cheap. This makes them special, but there are a couple of good wheels out there. But the general rule would be to go with not so super deep wheels. There's no reason to ride them.
What people thought was that the wheels do make a big difference in a package. So someone looking at buying a bike and they're going to get 50, let's say 40 mil wheels versus 60 mil deep wheels. I mean, the common knowledge, or what people thought, was that the 60 mils are a lot faster. I mean, have you not really seen that with the modern wheels that you're testing, that the differences aerodynamically aren't actually that big? Do you have any numbers on the difference? Okay.
It's not that big, no.
Yeah. Is that because the rims are wider now? Is that perhaps an old rule of thumb from maybe 10 years ago and it's changed because the rims are wider? Or was that never correct?
It depends on the overall profile you get, tire and rim interaction. And if the package is good, then you get good numbers.
Just on that sort of, but we were chatting earlier to one of the guys who distribute some of the Chinese brands. Have you had many of those, I suppose, more direct to consumer Chinese brands come through the testing protocol and the review protocol recently, and how have they performed? If there's any examples you might have.
No, I don't have examples. We occasionally try to buy something in China, but I think the products didn't make it.
I know you said you just sort of collect the data and you're not in control of distributing it, but like, you know, a website set up almost like Bicycle Rolling Resistance, but with all of the data we've just talked about, like I would buy a membership to that in a heartbeat. It would be really cool to have access to all of this sort of stuff.
Yeah.
I suppose the only other thing left to kind of mention was, is there a way people outside Germany can support the magazine and thus the testing?
Yeah, good question. Right now, the only thing we can offer is to buy the magazine, to have subscription. But unfortunately, it's in German only available. But come back to our website and see what happens. Hopefully, we have a different model at the start at some time.
Incredible resource. So valuable. Like anyway, we've talked about it, but we literally go week in, week out talking about all this stuff, and the answers are potentially really just at a magazine in Germany that we need access to. But that's another story.
Thanks, Robert, very much for your time and running us through all the information here. As Chris said, the testing you do is really great resource. So it's been really interesting to get some more detail on how you run that. So thanks for coming on.
Yeah, thanks for having me.